the Structural Engineering Podcast.
Hey, welcome back to the Structural Engineering Podcast. In today's episode, we're diving into the future of timber design with the team from Spec Toolbox. If you've been following the rise of mass timber, you know CLT or cross-laminated timber is changing the way we think about structures, offering sustainable, efficient, and innovative design opportunities. Spec Toolbox is making this process more accessible by developing software specifically for structural engineers working within mass timber. We'll talk about the challenges of designing with CLT, how their tools help bridge the gap between research and practice, and what this means for the future of mass timber construction. So, whether you're already deep into timber design or just curious about what's next in structural engineering, this episode is packed with insights you won't want to miss. Now let's get into the episode.
I'll get us started off. So you don't mind kind of telling us about Spec Toolbox and everything you guys are doing?
Yeah, thanks so much for having me on the podcast, Zach and Matt. So I used to work as a technical manager for a CLT producer in Australia called XLAM. And what we noticed was it was very hard to get new manufactured products specified by engineers, because engineers, a lot of the time, they go to university, learn a lot about concrete and steel. But when it comes to new products and new innovative products, it's not really taught at university, and curriculums can't usually keep up with innovation all the time. So, that's what's one of the problems. The other problem for new products is there's a lack of design infrastructure out there. So engineers, you're always building spreadsheets where there's gaps in infrastructure. So I was at XLAM, I used to build Excel spreadsheets, and I thought there's going to be a bloody better way to do this than everyone building this exact same spreadsheets, not only in one CLT manufacturer, but every engineering firm is building the same bloody spreadsheets, right? And there's a lot of design code changes. It's an evolving field, meaning maintenance of spreadsheets. So there's an unnecessary cost burden that comes with these new materials. So we decided to initially it was like, focusing on one problem, but since now and then it's turned into a platform. And it's the same problems across many product categories as well. So CLT, glue lam, screws. So right now we're building a platform for all modern manufactured products that have these technical bottlenecks to their specification as well. And we're lucky to just be launching now in North America as well.
Man, that's fantastic to hear. So even stepping back a little bit further, tell us about yourself and what drove you to starting your own business.
Yeah, I was always quite entrepreneurial. So I used to live a double life, and funny, just speaking to Max before this, he had a taste of my other double life, which was I used to be a podcaster as well. And so my entrepreneurial side, on weekends, I'd do side hustles. I'd start a whole bunch of things. A lot of them were flops, to be honest. Like I built an online course for graduate structural engineers. I did a podcast. One was called The Future of Structures. It was a bit of a flop, to be honest, but one podcast was good. We did a book. We used to read a book a week, interview authors. We wrote a best-selling book as well. So that was my entrepreneurial side on one side. And then on the other side, always as an engineer, I was really deep in the obsession of the craft, and particularly around this timber. Like my lecturer told me the future is going to be in sustainable building materials. And I used to be a bit of like an Elon Musk fanboy, to be honest, as well. And was thinking that just like the shift we've had in energy, it's going to come in structural building materials as well. So since uni, I was like jumping very early on this category. And luckily enough, the lecturer was right. That category has grown to be more and more significant now. And so that was my background. And then really I always used to have this belief that there's a book out there called The Alchemist. And The Alchemist says it's a book about following your heart in the direction of your dreams. And there's two things that really slaps me across the face. One of them was no heart has ever suffered when it goes in search of its dreams. And number two, if you stop listening to your heart stops speaking to you. So that hit me and said, all right, there's just something pulling me in this direction of starting something around this. And it started off with a very small thing, like a team of 2, and now we've got a team of 46 people all over the world just focusing on this space. But at the start, it just started with going in this direction, and all of a sudden the universe starts doing its thing, to be honest. And things start going in your favor, doors start opening, mates pop up who've been a long time, who know how to raise capital, join the team, we raise capital. A lot of things just happen at the right time, and that's really brought us to where we are today.
That's wonderful. So you gave us an idea of the software, but could you give us a little more direct? What does your software have that either other softwares don't have, or what typical designers are using today that is made better by your software?
So the software landscape today, if you think about a lot of the commodity products like concrete and steel, it's quite well covered. It's quite saturated. There is a lot of solutions out there. So you got analysis and design software. If you broke it up, analysis is relatively material agnostic, and Deliverable RFEM is probably an excellent one for when it comes to mass timber as well. That's widely recognized. But then when it comes to the design side, so you obviously got analysis working out the forces. Design is based on codes and analytical methods to work out capacities. So far, there's been a massive, massive gap there, and across the product categories that we're moving into, it's basically been held by two different ways of doing it. Obviously, Excel spreadsheets is the one that's most common, and we did a white paper, and it might be hundreds of unpaid hours of work in building spreadsheets, which is like hundreds of thousands of consultancy fees. It's not required for the concrete option for concrete and steel, and that is one of the reasons why it reverts back to the status quo rather than new materials. The other one is like there's a lot of suppliers build their own software as well. From their perspective, they'll build their own software because it's a top of funnel sales engine for them, because it'll be free for the engineer, and engineers will usually pick the supplier of the path of least resistance. So suppliers will compete with the other suppliers on becoming the path of least resistance as well. So they're the two areas, and we're essentially the first platform that's come in and said, well, from a supplier's perspective, we're going to save you a lot of money, because right now, you can focus on supplying products and being excellent at what you do, but we're a software company where we can, a tiny fraction of the cost partner with us, not even close to building it yourself, and we'll get the same outcome. From the engineer's perspective, it's like we give supply chain flexibility, choice, and design automation in that, because it's sometimes the supply chain flexibility is what drives down the cost for the client as well, and having that competitive tension. And the net result is growing the pie, because most suppliers in the mass timber industry recognize that it's such a small pie today. But if we focus on growing the pie as much as possible, then as a value, that all suppliers can get a chunk of the pie after that.
So I'm curious. Max and I have both designed mass timber buildings here in the United States. With your software being more global and being in different regions, what do you see that's done differently? Max and I have this viewpoint of the United States and the projects we've done, but what have you seen globally that is maybe different, or does it seem like most people are doing the same things when it comes to mass timber buildings?
It's a great question. I feel like US and Australia is quite similar, and probably Europe's a little bit different. If anything, I'd say Europe is probably just more mature in a lot of different ways in terms of its design codes as well, and the maturity of, say, the supply chain. Because if you look at some places, you got like companies that are hundreds of years old. I forget which company, but it was like 1,000-year-old company you came across. There's just ridiculous maturity there. But yeah, and the bottlenecks to specification are I think broadly similar, though, having said all of that. But US, all codes have their strengths and weaknesses, and I think there's different language, but prescriptive approach, I think the language you'd use in the US, and it's the deemed to satisfy approach, would use the language here. There is a lot of gaps in the building code for new products, and that means you are relying on performance-based design or expert judgment as well, because you just can't get around it, that you might have your PRG 320 and some design methods out there, but what happens when you got a beam penetration? How do you reinforce a notch? Some fire design, the shear analogy method for unsymmetrical sections. If you just go deeper, there's all these little gaps there, and then you still are reliant on external methods. Same with vibration. It's not in the building code for North America, but it's what governs floor design, for example. So, and the FB Innovations has got a vibration method approach, but the most mature method is from the latest Eurocode method, which allows you to specify floor performance level and fine-tune things. So it's like, that's where it's different. It's like, to do actually the best design, you need to sometimes borrow methods from around the world. But the challenge with that is you're still relying on expert judgment. So an engineer might be pulling from a code to in metric, sometimes in a German national annex in a different language from another part of the world, and it's the best method, but how you can actually solve the engineering judgment problem. So that's why, again, on our platform, we focus so much on education. There's a lot of more information drop downs. So, for example, if you were to pull the vibration method from the revised Eurocode, you'd click a little eye next to it, and you'd understand in detail. Well, we've taken it from metric to imperial for the US, and then integrate it with the US supply chain as well. So the user, you can still choose the FP Innovations or the CLT handbook method, which is a simplified vibration method. But at a click of a button, you can toggle it to another method from around the world and do the comparison like that as well.
That is great. Gosh. And just while you're setting the stage for us here, can you give us an idea, sort of in our head, what the software looks like and how we interact with it?
Yeah, so I think of a popular software in the US is EnnoCalc. I think that's a very popular design software. I've never used it, but people said it got similarities to what we're doing. So the way it works, you log onto the app, and then it is element-based design. So element by element. So you'll be able to see a floor, a wall, a beam, a column, a screw, a beam penetration, brackets, hangers, everything like that. And then you click the calculator you want to use. You open a project. So you create a project that you might be designing it for. That calculator will be stored in the project level. And then you can start building out your library of calculators within that project. And so, yeah, each one of those calculators, you can print PDF reports for certification as well. So we've just released single page PDFs and extended PDFs as well, because sometimes you need the extended PDF in detail because the certifiers learning sometimes themselves in these things, or you just do the single page PDF. So yeah, that's how it's housed. We do have enterprise panels as well, where you can have a full company have shared access to the same project as well on the software. And then on top of that, you got some extra functionality that you can do. So we do have partnerships with the supply chain right now. And there's our business model works in a really unique way as well, because we have a free version of the software at launch. So right now we're running a closed beta program, but when we launch, there'll be a pretty strong free version of the platform, meaning engineers don't have to pay anything. And then they can use a lot of the app and get quite a lot of mass timber design. And that's unique because most engineering software has got a free trial, whereas we're actually a free version, which doesn't change, And then the only thing is for the paid version, it's more flexibility. So you can manually configure grades, manually configure suppliers, everything like that. But on the free version, is our supply chain partners essentially who you can design without friction.
That's very exciting. Is it I'm going to mess up the wording here, but it's sort of a web app style, or is this
Exactly.
a download on your computer?
Yeah, it's a web app, and it just means like we are I believe I'm 90% sure this is true. We are like the fastest growing structural software out there because we are releasing every 2 to 3 weeks. It's basically unheard of for engineering software to have that release cadence of releasing better versions. So in 1 year, we'll have like 18 to 20 new releases with shear walls or whatever it is on it. And we can only do that because it's a web app. Web apps enable that quick release cycles like that.
That makes a lot of sense. And keeping up with people that make products like a Simpson, as they're going to update in a different sequence than a different supplier, you can just keep up with these.
Exactly, mate. Exactly. Because even understanding what the supply chain data is now, like we are the best option for getting what's most available on the supply chain. But even that, it's a hard database to manage because, as you say, there's all changes in screw families or what species of layups. Mercer's got 3 factories as well. Like what factory with what species of layup is most preferable to Mercer as well. So they're the sorts of things we're working with the supply chain now. So you can choose their factory and choose exactly what they want to supply, because the worst thing that can happen sometimes is like what gets specified on the engineering drawings goes to the manufacturer, and then all of a sudden they're like, well, we want to make changes. We don't, that species isn't the most cost efficient for us, or we don't source it in that part of the US, whatever it is. So it's like getting that manufacturing information at the fingertips of the designers as well, because there's not much of a cost difference between concrete and mass timber, for example. It's not an insurmountable difference, or even right now there is green shoots of more cost-effective projects. So it's like if you tick all the boxes and do everything right, you actually can get the cost be more cost-effective as well.
So I'm curious, Max and I have been asked many times on the podcast about lateral design. You brought that up using, maybe CLT shear walls or glulam brace frames. Does the software help guide that direction or have discussions? Because it seems like, definitely in the seismic design world, it's a big discussion point when it comes to mass timber.
Exactly right. Yeah. So we in our individual element-based design. So for the shear wall, it would give at the moment, you'd input the forces in it. So we've got a single level shear wall, but we're going to have a multi-level, we're going to extend that to multi-level shear walls as well. Then it gives you a stiffness of the shear wall. So you could go from first principles to that and then go to your, basic checks end to end on our software. Like the more powerful would be FEA, which is much more time consuming. But, sometimes to get an intuition on how the building works, I think our app is really good to work with, because you'll be able to specify the actual panel for the shear wall, the actual connections, get your stiffness, and get a mental model of how the force is actually being distributed in your building. And maybe that works really well in parallel to a more detailed FEA, because sometimes the FEA in this, it's very hard to get an intuition on exactly join the dots from first principles design to an FEA when you've got something as complex as these buildings, where you've got non-rigid diaphragms. Sometimes you can assume rigid diaphragms or flexible based on the connections as well of your diaphragm and then your shear walls. There's a lot going on. So I think and that's the one thing we have in our app, is to not be a black box. And it's good for the users, but also good for us, because if there's ever anything a user disagrees on, they can email us straight away and say, well, this looks pretty weird. And then, because we're on those release cycles, we can quickly fix anything up, change it, and again, clearly state whatever assumption is in text that we've got in the app as well.
Yeah, I really like the piece of it being a web app, because we often in the firm I work for discuss the programs that we have to download. There's a frequency of updates, but it doesn't automatically push the updates. You have to intentionally update the software, and it's always a question of, are we behind on it? Are we are those things updated constantly, or who's doing it, and those things. So I think the app based idea is really smart for what you guys are doing. I'm curious, is there any integration to any of the, I guess, common softwares maybe in the United States? It seems like we're finding more and more that different softwares integrating with our, more CAD softwares to do back and forth integration, things like that. Is that something you guys have now, or you plan to have?
Yeah, it's a very common request from our users. So it is underway for early 2026. So APIs into the broader ecosystem, and what is the interoperability of what we have to the broader workflow. And the short term thing for us and the lowest hanging fruit is just like simply bulk import export CSV files into the app, because you don't want to be just creating a heap of glulam or if you got different shear walls with different capacities, you don't want to have to individually do it. Like ideally, if you're using FEA, which can export to CSV, then get that CSV bulk upload and you're done. And then that's step one. But then following that is just like a direct API as well. And we would be in a really good position for an API, because we are the only, we see ourselves as one of the core apps that actually has an aggregated data set of the verticals that we're in. So for example, for screws, an API into screws, where our database has got all the different manufacturers themselves, but even a layer below that, you've got the individual screw families of those manufacturers. And then underneath that, and this is probably the most hidden, most powerful thing about what we're building, is we do build the generic design codes like NDS or CSA or Eurocode or New Eurocode or A1720, but we do build the generic codes, but we do also build the generic specific to the supplier's testing. So we actually go to their ICC reports, and that's where or their ETAs in Europe, We actually, and that's where you get extra capacities when you actually go to the individual buck test per supplier, and there's totally different rules compared to the generic design code. So even the geometry check, so what is this edge distance spacing, everything like that, it's different from screw family to screw family. So because of that, like you can literally get our API and it'll go to the ICC of Simpson or Rothelblas or whatever, and actually get to that level. And that is the it's probably the thing no one sees in our app until you get into the detail, that you can actually go to the click a button and go to the individual test reports of every supplier. And our partnerships with the supply chain is for that reason. Like when we partner with them, we don't just like upload a database. We go through a 12-week process where we build it specific to their testing. We change the calculation routines for that as well. They do a QA on top of that, and then it goes into that.
Going back a little bit, you had mentioned that, about being a black box, and it's something we deal with in engineering a lot. So walk me through that, of how you guys are not a black box, and maybe how you provide more of the back of house calculations.
Yeah. It's funny. Yeah. So when we were starting this thing, when I did the white paper, I interviewed a lot of engineers and the supply chain. And it's so funny how pretty much every single engineer I spoke to just said, I hate black box software. And it's crazy that all software is still a black box, even though it's like the one thing that engineers are screaming out for all the time. So that was from like day one. We had that in mind. So if you go to our app, a lot of our calculators in the calculation flows, it actually has, it's like a dynamic design guide. So if you picked up FB Innovations, you'd read a text to go with an image to show the point or something like that. Or if you think about the Johansson yield model, you'd see images of the failure mechanisms of how a screw fails in single shear or double shear, everything like that. So in our app, we'll actually make that dynamic. So you'll actually have a image of the failure modes to scale. So if you've got a steel plate and a timber, you'll see that. And then the screw as well, it'll be like all the imagery in the calculation. So as you scroll through, it's like a very deep, detailed, long calculation routine, step by step. And you could literally learn everything about the design you're doing with every calculator. Because we sort of targeted this not for those who are converted in timber, although they are our power users are timber naturalists, so to speak. But our target is like, what about if you're thinking about an office of like an Arup or something, and you've got 100 engineers, maybe 3 are timber specialists. We're actually targeting the 97 who might be used to concrete, but actually now with tooling, be able to pick up tooling and design timber with confidence. And for them, they need to pick it up and be able to read through it and build confidence. And as I said, it goes back to that engineering judgment. If they're relying on engineering judgment, you have to have education. So the calculations is one way. The other way is on all the inputs. This is somewhat common in a lot of software, but we go quite deep in this. When you click the button on the input, when you say choosing the vibration method, there's like a lot of education and references on each method to choose from. Again, so for analytical method, for example, you got the shear analogy method, which is the PRG 320 is based on. But a lot of users, that's just like baked in the PRG 320. Maybe no one's really thought about it, but there's an iron next to it where you can choose what's common in Europe, which is the extended gamma method, and it'll tell you the limitations of the shear analogy method, which users may not be aware of, and the limitations of the extended gamma method. And in doing so, they might find that you might get efficiencies because for a fire design, for example, you have an unsymmetrical cross section sometimes, and the extended gamma method is very powerful for the for unsymmetrical sections because it allows half layups, so to speak, better than the shear analogy method. But it doesn't account for shear deformation like the shear So, and we've been thinking about cost differential of just a marginal difference. These can be the difference between, say, a 7-layer panel for a CLT producer being reduced to a 5-layer panel, and thinking about all the manufacturing work in that difference. Again, it might be 10%, 20% cost difference. And all these little things add up to be the cost difference between the mass timber project winning at the end of the day.
Yeah, and that makes a lot of sense. We run into often contractors even are adding a lot of cost to it because they're uncomfortable or they've only done one or things like that. And I think the more data and conversation there can be, it kind of leads that. You were saying that when you're working with suppliers, there's a whole process of doing that. What have you guys found from that end of things as you go to these suppliers and say, hey, this is what we're doing, we would like to integrate you? Are they excited to be part of the platform? Or are they like, hey, we're actually building our own for our own software for our own product? Or what are you guys finding globally from the suppliers?
Yeah, broadly speaking, they're extremely excited. Like, because especially like all our partners in so the, what Nordic, Smartlam, Freris, Mercer, Sterling, they're all the KLH USA, Rotherblast, Simpson. There's a lot more, and pretty much everyone we've spoken to have been happy to join so far, and that's because for the same reasons I was saying before. It's like we are a platform that is focused on growing the pie of the industry, and that's probably like we are in a pretty cool industry in mass timber because that is a common value that all the suppliers share. It's like we're not trying to cut the pie. It's not a red ocean. We're actually in a blue ocean, this industry. And if we're sharing common technical problems, it helps engineers at the end of the day. It's a pretty easy sell to them because, as I said, they want to make it as easy as possible for engineers. They want to educate the industry on how to use their products and everything like that. So, and from them, it takes a big thing off a line item off their budget because if they were to build software themselves, some of them do, and they are great software as well. So, there is very good supply software out there, but a lot of the time that's a very big cost to incur. And then if one supplier builds that software, all the other suppliers have to follow suit to match them. So it'd be like engineers reinventing the wheel, building the exact same spreadsheets. If every supplier is going to build the exact same software, it's just massive costs for the industry. And that costs get one way or another ends up being the relative cost for the mass timber option compared to the concrete option, whether it's the engineering consultancy fees or the supplier's supplier price, baking in all the sales enablement costs that they bake into their price in order to sort of get spec'd at the end of the day.
I think the convenient piece too is like often you're picking between a couple suppliers sometimes, and the software would allow you to adjust that fairly quickly rather than going to each supplier's software and rerunning things. So I think that's that's a really fantastic piece of this.
100%. And what happens in the reality of the messiness of projects in the end of the day, it's like you design a screw and then it goes deeper into the process and all of a sudden they can't supply that screw or whatever reason you might need to change. Previously, you'd be in a lot of trouble then because it's, no, I got to go back to the ICC, what ICC reports, whatever. But like now it's like they duplicate calculator, no problem, swap, and it takes you about 5 seconds. So, and even for the CL, and how does that screw interact with the CLT or the glue lam as designed to, reading the species and the properties and stuff like that. So the interoperability of the categories we're in with the connections into the member design as well, reading the exact properties of the supply chain as well. It's a lot of automation downstream, which again, it's really hard, particularly on connections. Like that's when things get into the too hard basket, that's when everything just keeps going back to the status quo. So yeah, we just keep trying to solve those technical bottlenecks, so to speak.
That sounds good. I want to ask about education in your software. What sort of training or support do you provide for people that are using the software and want to learn more?
In our software, you'll see we're still pretty early. It's not that deep yet, but we do have a community. There's a couple of ways we do this. And one is a community forum. So in the bottom left of our software, you'll see this button called community. And when you click in that, we've got webinars we've done so far. We haven't launched our US ones yet, but they'll be coming soon. And then, so there's that. And then you've also got, for generic questions, you can ask questions to the community as well. And then, usually people jump in there as well. And that's more generic on mass timber. And the other thing on the bottom right, there's a contact us. So there's a way to reach us directly as well. But yeah, usually in our app, most success for us is like if you open up a calculator and we've nailed the user experience and user interface to the point where, engineers know what they're doing. It's like, all right, you flow the inputs right, first click your supplier, you're designing a beam or whatever it is. scans, load analysis, everything like that. So it's like if we nail the user experience, it's pretty self-explanatory. And as I mentioned, the only areas where um, education is really required is like, oh, why would I choose this vibration method instead of the other? And why would I choose this fire method, the analytical method? What does CM mean, this moisture condition factor? All these sorts of questions is the educational drop down. You click that and it'll give you the context and give you the reference. And so, yeah, that's our goal. And if we can't really nail that part, then it's not really scalable either for the users that we're trying to serve as well.
That makes sense. I know it was my question, but I've played around with the software and it is very usable. So I was just curious, but yeah, it's
Of course. Yeah,
it's
yeah.
very nice to use. Do you have any feedback or success stories from early users of Spec Toolbox?
There's heaps basically. So there's probably two categories. It's like there's one way I'd say success is like the engineers who previously couldn't do mass timber can now for a preliminary design. So there's one engineer, I won't say who, but for example, they wanted to get into mass timber, but they were doing a prelim design, then they got knocked out, and a very mature engineering firm ended up winning the mass timber project. That was like before us, and then the next mass timber project came along because they had our software. All they had to do was just buy a license for us, and then they were in the game, and then they could get into mass timber. You know what I mean? And not be worried about end to end what's going to come down the line, because they might be, all right, sweet, we can go to span tables and designing with a floor, we can maybe do a wall, but like, what about everything else? So our app helped them end to end. And then, following that, it's just like, for example, a beam penetration. And when I talk about this, a lot of this is ANZ in Europe, and depending on the time of those listening to this podcast, North America, this is all coming at some stage in the next, by the end of 2025, early 2026, so including what I'm saying now. But yeah, a beam penetration, for example, there's countless stories of before our software came along, an engineer would put their fee in for a project, not knowing what's going to come down the line. And then a beam penetration, mechanical services, unknown beam penetration happens where they weren't initially accounting for, and their whole entire budget is blown out of the water because of that, because it is so complex to do, let alone reinforcing it and everything like that. And again, another example where I think NDS in the US has some versions, but the German annex is probably the most advanced globally. So to go to that, and that's just, it blows out time, but use our software, all those things are totally eliminated. And then you can, it takes like an hour and it de-risks a lot of that. So broadly speaking, they're the stories we get from a lot of our users as well.
So I'm curious, with you and your team being on the forefront of mass timber and putting together all this software, what are you guys seeing as the most exciting advancements or potential developments in just the world and of mass timber and the technology? Like, what are you seeing coming down the road that you're excited about?
So yeah, I'm super excited, obviously, but I think there's, in a macro sense, like if you think about concrete today, in situ concrete, and think about how mature that industry is, it's slow to build, it's slow to design, and it's stagnated innovation for 50 years. A lot of people have probably seen that curve of construction productivity just really gone nowhere. And I think it's because you can't innovate to actually, well, maybe I'll probably eat my words by an email, someone PhD saying they've figured this out, but like speeding up the curing time of concrete, it's really a bit of a bottleneck waiting for that to dry as well. And manufactured buildings, so particularly in the mass timber products, it does offer a new jump in an S curve. So whereas concrete, it's mature when it comes to mass timber, we're still at the start of something, and there's so much fruit to pick off the tree as well. And right now it's plus or minus five, well, maybe 2% cheaper to 20% more expensive. It might be in that range, depending on how you design the project and a lot of different variables. But there's so much fruit to pick off the tree, you can actually get that to minus 20% cheaper to cost neutral. That's like the potential of this category as well. And it's heading in that direction. And like we're sort of, there's a lot of people working on different angles to achieve where that direction ends up. But construction is a cost-driven industry. There's no way around it. Like, sustainability is great, but it isn't what wins projects. So what gets me most excited is the cost efficiencies getting better than cost neutral, and what that's going to do for the industry as well. And we can go into a lot of the detail of where the cost efficiencies are and anything like that. But that's what gets me excited.
Yeah, no, I like that. I like that a lot. I think that makes a lot of good sense. This more or less new world of AI and software and all of that. Are you guys looking to integrate that? Is that part of your workflow or process now? I know it's a very broad question. I think a lot of people are still trying to figure out what is AI and how
Yeah, I was
that
going to say,
works.
we know what Chat GPT is. We do not know what AI is in the sort of category like that.
Yeah, it's a good question. Well, I don't know. We're just like all engineers, just waiting and looking to see what's going to happen. Like we see ourselves as providing tooling for the engineers, and maybe AI. We see AI as helping us accelerate our product build. I'd say more than anything, and then build better and more intuitive tooling for engineers, and then because engineers at the end of the day is still always going to be like you're not going to like we speak to investors and stuff, and people who aren't engineers might assume you're just going to put in a chat GPT prompt and design this building. And it's just, there's just such a big jump before it gets there. You can't see it on the current horizon now, right? So it's like, you're going to need someone's skin in the game. You're going to have, building codes aren't going to allow that. For building codes take a long time to change. I don't see them letting ChatGPT prompts being a pathway in the building code, right? So you're still gonna need engineers doing the certification, the design. So like we're positioning ourselves to build tools, and AI might help us do that. Of course, we can integrate chatbots. We might be able to put an open AI thing in there where if you're designing a floor, you can ask about durability of this, or what is the local supply chain here? What is the sustainability and the broader context around the computations as well. And I think they're probably it's a dangerous thing to say because AI, you never know how quickly it's going to jump, but there still hasn't been that big breakthrough either when it comes to engineering as well, right? Like on math as well. There's a long way before you start trusting it there. So we just have it accelerating our product build, but we need to. You can't do sloppy code with AI yet either. Like you could get a chunk of code, but it takes just as long to QA. You still need a really experienced, good team who know what they're doing from a software development perspective as well to understand the code as they're building. So you can't do vibe code in engineering software either as well. So it's not yet anyway. So it's still the mix of knowing the context of it, but it does help our build process as well.
Is there anything that you're working on right now with software, like a new modular capability that is being developed for future use?
Yeah, the biggest one we're working on is profession expansion. Most engineering software expands. So we got two options, right? We could expand deep into concrete, steel. We could try and expand to be a generalist software, but our expansion strategy is more profession expansion for manufactured products. So it's still staying in this category, but because if you think about particularly in mass timber, a lot of the professions are like this, and because if you got a CLT floor, if you expose the underside, it might have an impact on fire and aesthetics, for example. So it might be tick there, but then all of a sudden your acoustics might be out. And then what about flanking? What about the cost of all that? So like we're sort of going in that direction to have to stack professions a little bit like that. And then so you'd still have the engineer using our software, but they could easily work out an acoustic system to go with it for your airborne impact sound rating and fire and everything like that. And then, as you're doing that, we can put in the EPDs to work out the sustainability performance of that, not just the individual panel, but the entire system relative to a concrete building as well. Because that's the thing at the moment, a bottleneck for projects is like you could have a 12-week, it could be the mass timber project sitting there for 12 weeks, so to speak. And all the consultants, so structural engineer, fire, sustainability, acoustic, cost. And if you got an experienced team, then there's no problem. But sometimes that process, you might be toggling through a lot of different alternatives, and the developer, it might just get quite hard for the developer in week 10, and they go, "Oh, let's just go back to concrete." You know what I mean? But it's sort of like that optioneering piece in that early stage is where we'll be supporting across professions. So very quickly you can toggle the actual system, get an understanding of it, design it, and then goes on to prelim, and then later you can go into detailed design as well.
So for anyone listening that hasn't designed a mass timber building, what would you say are the top couple things that they should think about? What would your software lead them to realize or understand, or efficiencies? Or what would you say if you sat down with a brand new engineer or even a senior engineer that's never done mass timber, what would be your guidance to get them started?
Yeah, it's the biggest guidance, to be honest. It's even outside our. It's a step before our app. Our app is, you know, our app is probably a step down the line. But I think it's when you're designing mass timber, it's designing a square peg in a square hole. The worst thing we could do is a square peg in a round hole, and that is like you get trying to get concrete building and jam a mass timber building into what you're used to in terms of grids. When it comes to mass timber, you're going to compromise in certain spaces for sure, like your grids. But then you're going to have benefits. You're going to have exposed, beautiful building and sustainability benefits. So it's understanding you're going to have compromises in places. It's harder to deal with transfers, for example. All the one-way spanning system versus two-way PT slabs, like all these little things. And if you get that right, next step is just to think about the bottlenecks. So that you don't need to think about this deeply. It's like, what are the bottlenecks to the supply chain? So the bottlenecks can pop up in manufacturing. You know, what is the limiting factor of, say, this CNC machine? How big's the panel can be? Usually that's not the bottleneck. The bottleneck's what goes next is the truck. So if you think about, start with the truck, it might be a 12-meter truck, which I think is about 30 foot. What's your standard trucks? I think it may be 36 feet or 40 feet or something like that, whatever it could be. And if you think about, if that's the limiting factor, your installation speed is the same for a small panel or a big panel. So if you design your grids only a little bit different, all of a sudden you might be trucking half air onto the site, and when you install it from your crane, the installation speeds are half because your panel size is half the size. And remember, the cost savings is usually tied to your speed of construction, which is your prelim. So your site infrastructure, your cranes, your workforce, all that sort of stuff. So if you can really drive up the installation speeds, it drives down the cost. And it just always just goes back to a simple grid layout, like very basic stuff. Getting the grid layout could be good from a manufacturing perspective. And the best people to speak to, I think, is the supply chain. Our software is obviously great. It does educate as well, but there's a hesitancy with speaking to the supply chain early because you want that tension within the supply chain and competition. But there's so much value from the supply chain knowing exactly what their constraints are to manufacturing. And when I used to work at a CLT producer, our costing spreadsheet it might be double or triple the price based on the manufacturing complexity and the CNC complexity. So people ask, what's the cost of CLT? Well, it's like, well, it depends. Design it well, and the speed and your supply price might be half as much even, and then you can drive it way down.
That puts a really big value into planning ahead of time and having the engineer involved in the project from the get-go when they're laying things out.
100%, Max.
Well, while we're getting to the end here, what questions have we not asked that you think are important that we should talk about?
I'm glad you asked the question at the end, because it's like, I think it's the what I'm most passionate about, as I mentioned, is costs. It's like the triple bottom line is sustainability and biophilia and cost, and the first two are irrelevant if you don't get the third right, and all three are possible as well. And I think the wastage that can happen with unnecessary cost blowouts, which are totally unnecessary, is something that is going to move the industry as well. So so I'm glad we got to cover that. And it's knowing you can design the most complex structures in the world, like structure craft projects and the most beautiful things in the world. And timber can do that extreme really well as well. But know what you're designing. You can win all the timber design awards in the world for that design. That's possible. And then but if we're trying to do cost effectiveness, it's the other way. It's simplicity as much as possible. And it's usually when we're trying to expect costs but have this advanced design as well that we sort of get meddled. So it's like backing the horse that you want to go with, and then following it through as well.
Yeah, Man, what a great way to end the podcast. Well, thank you so much, Adam, for taking time. Unfortunately, when I did the mass timber building years ago, I didn't have your software, and I'm just like sitting here
You were
thinking
on
about
spreadsheets, right?
I was doing spreadsheets and the efficiencies, like not even like a sales pitch, just like from an engineer, like, man, this would have been so fantastic to be able to utilize. And I know Max just finished up a fairly tall mass timber building, and he probably has the same sentiment. So thank you so much for everything you're doing and just moving engineering and sustainable projects forward.
Thanks so much, guys. Well, and thank you for doing podcasts like this. These are amazing, and putting good education out for curious engineers. Like all three of us were probably as grads, like we were all super keen listening to podcasts and stuff like that. So yeah, great service that you guys do.
Thank you.
Sweet.